Hello, Keith Rucker here, VintageMachinery.org. Guys, today I'm over here at my Kearney Trekker horizontal milling machine and getting ready to kind of set up this vertical head on here again. We've used this previously in some jobs, or at least one job. I've got another job coming up that I want to use it on. And the last time I used this, when I put it on, it was the first time I'd ever used this actual high-speed vertical head on my milling machine. But I noticed after we kind of got it set up that it wasn't trammed in just like I really wanted it to. When I say trammed in, it wasn't running perfectly vertical to the machine. I had a big face mill on there, and I was noticing as I was making a cut, it was cutting a little bit more on one side of the cutter than the other, which indicates that the cutter wasn't flat. It was tilted one way or the other. Wasn't a huge deal for the particular job that I was running at the time. I was basically able to just continue my pass across. It cleaned itself up, but I wanted to get it trimmed a little bit better for this next job that I've got coming up. And what I did previously was I just used the dials on here and I just dialed it in 0, 0 as close as I could get it with my eye. But yeah, it wasn't really close enough. For the job I was doing, it was fine again, but it really should be better than that. So anyway, we're going to actually try to tram this mill head in today and get it set where it is going perfectly vertical for the next job that we've got coming up on this. So let me show you how we're going to go about doing this. I tram in my vertical mill frequently, and I've done some videos on how I do that using a cylinder square. And it's a pretty quick, easy way of doing it. And there's lots of ways to tram milling machine heads. A lot of people will use an indicator. I've got some indicators that are made to go on a vertical head for you can dial it in and use that. And that works great. But I find that the cylinder square trick is faster. And I have previously in the past trammed the head in with the cylinder square and then put the indicators in to kind of verify and see how good I am. And I'm within 10 thousandths of an inch. When I say a 10 thousandth of an inch, so less than a thou, 1/10 of a thou, or some number less than a thou anyway. So for most jobs, the vast majority of jobs, that's more than adequate. So that's what we're going to do here, is use a cylinder square. Let me show you my process. I will say that this head is a little bit aggravating to work with. It rotates on 2 axes, so you can actually rotate it on this here, where you can rotate the whole head where it'll go left and right to the front, and then also this front piece here will rotate, so you can really get a lot of different angles in here. But what really makes it difficult to adjust is that when you loosen the bolts up to do it, there's nothing like you can put like on my vertical mill, like there's a worm gear in there, and you can basically take a bolt and you can turn it and it will actually adjust that head, and you can do very fine precision adjustments with it. With this head, once you get it loosened up, it's just moving, and you really have to be careful and bump it around. Or if you're not careful, it'll just kind of fall out of place. And the worst one is this axis back here, because the way this is, the weight is all cantilevered over to one side, and the weight naturally wants this thing to drop down where it's running down flat. So anyway, we're going to go through the process of how I'm going to do this and show you those tricks. Let's get her done. So we're going to start by putting a tool holder in here. This is just an end mill holder on a 40 tanker. This is actually a brand new, and I just purchased. I didn't have one this size, and just went ahead and just bit the bullet and got a brand new one that I know is running nice and true and everything. This one takes an NMTB 40 taper. If you look in the catalogs and stuff, you'll find a specification, or you'll find these available in either NMTB 40 or CAT 40, CAT 40. The taper is the same on a CAT 40 versus an NMTB spindle. The big difference is on the NMTBs, the top up here is a little bit longer, and I think it may have a different size drawbar. I'm not sure about that, but it tightens it up. Basically, the CAT stuff is what's used on the modern CNC equipment, whereas the NMTB is what fit on the older style machines. NMTB stands for National Machine Tool Builders. It was a standard, and it's still available. You can still get these. A CAT 40 will fit in this. You can make it work, but you really can't make the NMTB stuff work on a CAT machine, but they are backwards compatible. Again, though, I'm not 100% sure on the 40 tapers, but you may have to use a different size drawbar, but you can make them work. But I did order an NMTB because that is what this takes. So it just fits up into the socket in the bottom. This is a drawbar on the top, so we're just going to screw that in there. All this drawbar does is it screws in the top of that, and when I tighten up this nut that's on here, it's going to draw it together. It's going to pull that into that socket, into that taper below, and it should be running really nice and true. That's the game plan. So let me get a wrench here. We'll tighten that up, and we should have that mounted. All right, we got that drawbar tightened up, and that is nice, sucked up into that socket, and it should be running true with the head. Now the next thing I'm going to do is I just ordered a piece of ground rod. This is a 1-inch diameter ground rod. It's very precision. It's very uniform in diameter. It's very straight, and that will fit up into this tool holder. I need to get something loosen these set screws in, but that's going to give me something to actually that I can work off of, this shaft, to make my measurements again to get everything trimmed in. Let me get my set screw here, and we'll get that mounted in there. All right, we'll loosen these up. Now this will go up in there a good little ways. That's a really tight fit. You can feel the suction actually just holding it in place. And we'll leave it sticking out. I mean, how long is not critical. We'll just go about that far right there. And I'm not going to crank down on these. We're not machining anything with it. I don't want to mar those up too bad. But this now will give me a surface in relation to the head. This is actually just the same place we'll be mounting an end mill, so this will be exactly the same type of a setup, that we'll be actually mounting a tool in here with, that I can measure off of to see if my tram is right. So there we go. We got something now to work with. I'll get my cylinder square, and we'll see if we can't get this thing lined up. I've actually got two different cylinder squares, two different types of cylinder squares. I'm just going to introduce these tools to you if you've never seen one before. So the first one here is a magnetic cylinder square. Pull it out, and I got a nice wooden box that I keep it in that keeps it protected. Basically what we got here is a magnet on the bottom that allows this thing to stick to whatever you're putting it on. It's nice, and I use this a lot when I'm rebuilding machinery and doing calibration work or checking things for squareness and stuff over on my surface plate. But the nice thing is you can actually mount this to something sticking straight out the side, and then on my surface plate I can come in here and measure off of this, and if you got the same measurement in two different places, it indicates that that surface is square that you're working on. So this is a neat one. This is the first cylinder square I got, and it works just fine over here. But when I put this down here, basically this cylinder that's going up and down has been precision ground to be perfectly square in all directions. And when I say perfectly, I don't guess there is technically anything perfectly perfect, but it's within, a 10,000th of an inch or less square. And again, for the application we're doing here, that's plenty good enough. It's actually better than that. At least last time I checked it, it was. There's no reason for it to have gotten out, so I'm assuming it still is. So anyway, this is one type of cylinder square. This is honestly the one that I use the most. This other one over here is an interesting one as well. This one's made by Brown and Sharp, as you can see on the box. And this one's actually kind of a rare bird. They didn't make this for very long, and they didn't make very many of them. If you can find one of these, they're getting kind of hard to find. They're getting kind of expensive when you do find one. But this is another type of cylinder square. It just sits flat on the table. There is no magnet, so you can't stick this on the side of something. It is a little bit larger in diameter, which is nice for some applications. And it's just heavy. It's real heavy. So again, it gives you some stability there while you're going. What's unique about this one is if you look around it on you see the markings that are kind of engraved in it. This one's interesting because depending on which side that you place on the table, it's either going to be perfectly square all the way around, or it's going to have a slight taper to it in one direction. In other words, it's going to lean over very slightly in one direction, and that's where these lines kind of come in here. So you can put this up against something and turn around until you get up where you don't have any light shining between and whatever you're measuring up against. And then looking at the marks on here, you can determine how far out of square it is. And basically these starts with a 0 on this one. On right here, if you put it right on that straight up and down line, it's perfectly square. If you come over one, this is 2/10,000ths of an inch out of squareness over however long this is, 6 inches, we'll just say. And it goes to a maximum of 1.2 thousandths out. Now, if you flip it over to the other side, this side, when you put it down, and it says it on the top, you can't read it, it says this end up for true square. It'll be square all the way around. When you go in this direction, basically it's going to be tilted one side or the other, and you can measure that tilt while you're doing things. So for what we're going to be doing it straight up and down, because that's what we want to use it as a reference. Now, I think I am going to use this one here today just because it's a little bit larger, it's a little bit heavier. It just kind of fits on the table pretty good. I could use this one just as well. I use this one over on my vertical mill all the time when I want to tram it in. And I use a similar process over there, but instead of using a spindle like this, I just drop the actual quill down without a tool or anything in it, and I can look at this surface compared to the quill, and I'm just measuring it up directly. And again, if I get where I put a flashlight behind this and I can't see any light, it's so square that, when I put the indicators on there, it's as good as doing it that way, and it's a lot faster and a lot less aggravating. All right, so you've been introduced to a cylinder square. Let's go over here and get this set up, and we'll get an idea of how far this thing really is out. I don't even know right now. We're gonna find out. So first things first, I'm just going to take my precision ground flat stones here, and I just want to stone this table where we're going to be putting that cylinder square. As you can tell, my table has seen a lot of use over the years. I just want to make sure that we're working off of a fairly good surface. This is going to knock down any high spots and burrs. It's not going to take down huge amounts, but I can feel there's some little catches on there, and I can see it shining up, but this will give me an area on this table that I can work in, and I think we're good there. So I'm going to get my cylinder square here and make sure everything's clean. This end up for square. Put it in there. I need to raise my table up a little bit. I'm going to cheat and use the power feed. That's good. Now, I'm going to carefully just bring the square up against the cylinder, or cylinder square up against that spindle. And we'll be able to tell very quickly how far out it is. And I can tell already it's leaning a little bit. It's more or less touching at the bottom, and you can see a fairly sizable gap up there. This thing needs to swing out away from me in the bottom. So let me get some a wrench here to loosen this head up, and we'll see if we can make an adjustment, see if we can get that straightened out. All right, we're going to loosen up the bolts that tighten all this down, and I don't want to completely loosen it. I want it to be a little bit tight still, but hopefully loose enough that I can adjust it by bumping it around. It's kind of my game plan here anyway. A little tension back on that one. All right, and we need to go out on the bottom and on the top. Let me get a dead blow hammer and see if I can just bump it around a little bit. All right, let's take a little dead blow hammer here, and I can tell I moved that over a little bit. Just, you'd be amazed at how close you can get something with your eye by just making some little adjustments like this. Now I need to bring that table in, and I've actually got controls back here on the back of my machine to do that with. And that's real close. It needs just a little bit more though. I'm going to tighten the head back down this angle. And let me get a flashlight and I'll kind of show you guys what we got here. All right, we come here with a flashlight. And I mean, you can see some light coming through there, but it's uniform all the way up and down. I mean, that thing is right where it needs to be. That's great, and I promise you again, if I were to put an indicator on here and swing it around like you do with a lot of the tramming devices that are out there, it's going to read less than a thou, by way less than a thou. This is really good. But this is only one angle direction. We need to do the other angle direction. So now I need to do is basically move my head out, and we'll do the same thing, 90 degrees to that. So basically up and down this face and on the side, and we'll have to adjust it in the other direction there to get it lined up as well. So let's get that done. So I got you now looking on the front of this, and I'm actually surprised. It's pretty, I mean, it's really right on the money right here. I mean, I think you could argue that it's touching a little bit heavier in the bottom than it is up in the top. In fact, we can check that. Let's put it over here on the tilt side. I'm going to come in, put my 0, this is straight up and down. And what I'm going to do is I'm just going to rotate this around, and I'm probably going to have my arm here, and well, I don't know, maybe not. I'm just going to rotate this around until I get a better fit, and we can get an idea of how much out it is. It's not out by much. So that looks a little bit better to me right there. And that's 3/10,000ths of an inch out of being perfectly square. And honestly, guys, it's just not worth the effort. I know that if I loosen this thing up, it's going to want to tilt out because of the weight, like we mentioned before. So I think we're just going to leave it like it is. But that's really the cool thing about this particular cylinder square is that you can, if you got something you want to see how far out it is, you can actually use this one to measure it. Now, I'm assuming that's 3/10,000ths per foot. I'm not sure if that's per foot or per 6 inches, which is roughly the length of this square. I need to find some documentation to verify what that is, but it really doesn't matter. In this case, it's good enough. We're going with it. So there you go. I think we're going to call that trammed, or at least as trammed as it's going to get. Well, there we go. Quick, easy way of tramming a milling machine in. This one's a little bit more complicated than a typical vertical mill, but same process here can be used, and I really like this method. I've shown it before. It works great. It's fast, it's quick, it's easy. You're using your eyes to look at the difference in a gap from top to bottom, which is surprisingly accurate. Very precision, a lot more precision than people give it credit for, rather than looking at dials on the indicator. Sometimes when you're looking at dials on the indicator, there's a certain amount of variability in your readings that you can just get from that in itself. So, keep that in mind. I think sometimes some people give me a little bit of flack every now and then about my level of precision. They're like, sometimes I'm over here scraping a machine in and I'm going for absolute perfection. And, I'm fighting over 10 thousandths of an inch. And there are other times it's like, oh, that's close enough. And guys, I think that's something that everybody needs to spend a little bit of time thinking about for the job they're working on. What is good enough? I think sometimes as machinists, we try to do everything perfect, as perfect as we possibly can every single time. And, there's nothing wrong with perfection, but the problem with perfection is that you really can't reach it. And when you talk about precision, what is precision? Yeah, I mean, if my micrometer reads to 1,000th of an inch, that's precision. But if I need something to be to a 10,000th of an inch, that's not good enough. So if I need something to a 10,000th of an inch, or I got a micrometer that reads to a 10,000th of an inch, but my part is spec'd out in millionths of an inch, again, doesn't matter how close you get something to whatever tool you're measuring it with. I promise you there's higher levels of precision that you can get to. So when I say something, is dead nuts flat, that's really not true, number one. But it's usually true enough for the situation that I'm in. And for me, I'm doing mostly repair work. I'm doing job shop work. I'm making one-off parts. Oftentimes, my parts are not made absolutely perfectly to the original specification. They're made more to fit because there's usually wear involved and things like that. So, you keep all that in mind too. If you're in a manufacturing machine shop and you're making parts for an automatic transmission or a manual transmission in a vehicle, and there's an assembly of 10 parts that go on a shaft, you have to make sure you're making those parts very precise because there's 10 parts in there. And if each one of them is off just a little bit, that tolerance that you have, it can multiply. That the precision multiplies out, which is why very often they have very, very tight tolerances on those parts because, on the individual parts, you might be able to have, just say 10 thousandths of an inch, plus or minus 10 thousandths of an inch of a tolerance to make it work right. But if there's 10 parts in there and each one of them is off by 2 thousandths, well, that's under the plus or minus 10. But say they're all plus 2, when you add them all together, now you're 20 thousandths out over that distance. So that's why a lot of times we have very precise precision measurements on something. It's because of that creep effect that can take place in manufacturing. And even though the part's in spec, when you assemble everything together, it becomes out of spec. When I'm making individual parts, and again, making repair parts where there's wear and everything else, sometimes my tolerances don't have to be as great as what the original specification was for it to work properly in the application that I'm doing. That's something that you just kind of have to learn over time and get some experience to figure out what is good enough. And then too, you have to, where am I going to fight my battles? Am I going to sit here and worry about, okay, to be perfect, I need to take an extra thou off of here. I know I've got a plus or minus 10 thou tolerance on there, and I make one more pass, and then boom, now I'm, instead of going 1 thou, I went 12 thou, and now I'm out of tolerance. So, a lot of times when I'm thinking about what I'm doing, is it good enough? Is it good enough for the application? And for this case here, 3 10,000ths on that side over here. I did check it on the tilt on the other side. It was about the same. This thing it's good enough for what we're going to be using it for. In fact, it's way better than it needs to be for what we're going to do it for. So I'm not going to pull what little bit of hair I have left out shooting for perfection when it's just not worth the effort. So anyway, that's my thought on it. Some of you guys out there will probably disagree, and that's fine. If you want to go for perfection, go for it every time. I'm not perfect, so I know my limitations. There you go. Guys, with that, we're going to call this a wrap. We're going to get this machine set up and start doing some milling on it here very soon. We'll have another video coming out on that, but I needed to get this done first, and I thought I would share with you guys this method. It's been a while since I've shown using a cylinder square to tram in a mill machine head, and this is a little bit different application than the last one we did, so I thought it was worth repeating if you haven't seen that in a while. And there you go, and you got my thoughts on precision as well right, wrong, or indifferent. Those are my opinions, and I'm going to stick to them. Guys, we'll catch you on the next video. As always, thanks for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted to the site. Big, huge thank you, as always, to the subscribers of the site, as well as those who support the site through Patreon, PayPal, etc. Really makes a big difference. It allows me to be able to take the time to shoot these videos, get them edited, get them out there, which does take a lot of time. With that, again, we'll catch you on the next video. Thanks for watching.